Hello, this video is going over Vesper shapes, and to do that I'm going to do a few problems from your molecular geometry homework. I am not going to do the Lewis structures, so we're going to start these problems with the Lewis structures already done. If you need help with Lewis structures, watch the Lewis structures video, but this one we're going to go over molecular shape and bond angle, the name of the shape, if it's polar or nonpolar, and I'm going to go over how to use the Vesper model handout to figure out what the shape is without having to build the actual compounds. So we're going to go through a few of these together. Again, not doing the Lewis structures, but go through these. This is from your molecular geometry homework, which is to be done in your notebook. So you do not have this handout, you'll just copy it into your notes. Okay, so we're going to start out with this one, PCl3, the first one. Lewis structure is already done here. And basically what I'm going to go over is how to use this handout. This handout is very, very powerful, very helpful, but only if you understand how to use it correctly. So I'm going to go over how to use this handout with your molecular geometry homework. You'll probably want a version of this. It doesn't have to be this big and detailed, but you'll want some type of table like this for your note card for the test. So if we're doing the Lewis structure, this is the first thing you need in order to figure out the shape. You have to have a correct Lewis structure. Once you have that, if you look at your central atom, the whole idea here is that we can determine the shape based on how many electron domains are around your central atom. So an electron domain is defined as either a single bond, double bond, triple bond, or lone pair. All of those things count as one electron domain. Okay. So on the first example here, PCl3, I'm going to go and circle the electron domains, but you do not have to do this. Okay, but around our central atom, we have a lone pair. That's one electron domain. We also have a single bond here, we have a single bond here, and a single bond here. So that means that there are 4 total electron domains around our central atom. So we'll go to our handout and go to this. So there's different options here, but this one has 4 total electron domains around the central atom. Once you know the total electron domains, you want to figure out how many of them are bonding. In other words, how many of them are lines, and how many of them are non-bonding, or how many of them are the lone pairs, the dots of electrons. So in this example, we have 3 of the electron domains are bonding, so we'd go to 3. And that automatically brings us to one of them is non-bonding. That's correct. So that leads us to this shape pyramidal, and it has a bond angle of about 107 degrees. So that automatically gives us the answer to this molecular shape and bond angle. So actually here we put the name of the shape. So the name of the shape is pyramidal, which we got here. So for the name of the shape, I'll just use red. Okay, that's pyramidal. And then this handout also shows you how it needs to be drawn depending on what the shape is. So for example, for pyramidal, the way we draw a pyramidal shape is by showing the 3 bonds pointing down. So you have to draw it this way. Lewis structures, you have a little bit of freedom in how you draw it, but the shape has to be drawn this way to convey that it's a pyramidal shape. So to do that, I take the phosphorus, and then just like it is on the example here, the 3 bonds need to all be pointing down. So we'll have bond, 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 and then these are CLs. Okay, and remember on the shapes, we do not include the lone pairs of electrons. So that's actually all you write down, and that looks like the example here. The last thing for this box is the bond angle, which again, if you use your handout, it tells you that it is about 107. So these angles here are about 107. And just so we can look at this, remember that a tetrahedral shape would have bond angles of 109.5. So since you have a lone pair above, this blue thing represents the lone pair is bigger, it takes up more space than a bond. So by having it there, it's going to push these bonds down, making the angle smaller, so you get about 107-degree angle. Okay, and then this will also be helpful for us with our polarity. The last thing we need to answer is if the molecule is polar or nonpolar. And if you look back in your notes, you have a few questions that you can ask to determine the polarity. Sorry, this is really close. The first one is, are there lone pairs of electrons on the central atom? So we look back here, this you'll use the Lewis structure. There are lone pairs on the central atom. And then the second question is the central atom bonded to different elements? This one, it's not bonded to different elements. They're all chlorines. However, if you answer yes to either question, it's polar. So the fact that we have lone pairs on the central atom makes this molecule polar. The reason being, remember, polarity is all to do with symmetry. And if you look at this molecule, what's up here is different than what's on these bonds here. You have chlorines bonded here, but up here you have a lone pair, and that's different. So since you have one side of the molecule that's different, it makes this molecule polar. Okay. All right, so that's the first one. Next, we'll go to H2S. And again, we're going to use the handout to figure out the shape. So we look at the central atom, and we look at the number of electron domains around the central atom. So there's one, there's one, there and there. Again, you don't have to circle these. I'm just trying to highlight this. So we've also circled 4 electron domains, like the last one. We have 4 total electron domains. This time, 2 of them are bonding, and 2 of them are lone pairs, non-bonding. So that leads us to this bent shape. Bent with about 104.5 degree bond angles. So this is bent, and to draw this, if you look on your cheat sheet, we actually have to draw it bent to show the shape. So this one, we have S here, and then we have to have these bond angles showing bent, and it's about 104.5 degrees. So this angle here is about 104.5. So it's smaller than 107. And the reason, again, is because it has 2 lone pairs that are taking up a lot of space. So the previous one had 1 lone pair. This one has 2 lone pairs. So again, it's making these bonds get even closer together, pushing them closer together, because the lone pairs take up more space. Okay, so this is the bent shape. And for polarity, again, we ask those 2 questions. Is the central atom, or does the central atom have lone pairs? Yes, it does. So automatically, after we answer yes to that question, we know that the molecule is polar. Okay, lone pairs on the central atom always make it polar. So it's done with that one. All right, the next one, CBr4. So let's look at our central atom to determine the shape and try to figure out how many electron domains are around the central atom. All right, so we've got 4 electron domains again. So 4 total. All of them this time are bonding. All 4 of them are bonding. There are no dots on the central atom. So this is everyone's favorite shape, tetrahedral. Tetrahedral has bond angles of 109.5, and when we draw it, we need to kind of show this shape by 1 pointing up and then the other 3 pointing down. So we'll copy that here. Carbon is in the middle. One of the bonds goes up, and then the other ones all point down. Remember, leave off the lone pairs. So there's the shape. Bond angles are 109.5, and we have an example of that here. So this has the 109.5 degree bond angles. No lone pairs, so all of these angles are 109.5. They're not being pushed closer together. Okay, and when it comes to polarity, we have to go back to the Lewis structure and ask, are there lone pairs on the central atom? No, this one actually does not have lone pairs. So then we need to check the other one. Is the central atom bonded to different elements? No, they're all the same element. They're all bromine. So since we answered no to both of these questions, right, it's only polar if we answer yes to one of them. We answered no to both of them, which means this molecule is nonpolar. So nonpolar means it's totally symmetrical, very even, very balanced, and we can see that if we look at the model. All sides are the same. You could put this any way and it looks exactly the same. Okay. All right, let's do BrCN. Okay, this one's a little funky looking. Hopefully you got that correct Lewis structure. It's a little tricky, but when we're determining the shape, we're going to do exactly what we did for the previous ones. We're going to look at the central atom and figure out how many electron domains are around it. So I see one electron domain here, and then here's where it gets tricky. This triple bond, that is one electron domain. Remember, the definition of an electron domain is a single bond, double bond, triple bond, or lone pair. So a triple bond counts as one electron domain. So this has a total of 2 electron domains around it. So you go all the way to the 2 on electron domains, and out of the 2 of them, both of them are bonding, right? So we go to 2 bonding, 0 of them are lone pairs, which leads us to the shape linear. Very easy shape. And as you should guess, to draw linear, it should be a line. So we need to draw these atoms in a straight line. So we'll do that. Carbon's in the middle. We do have to show the triple bond, but we do not show the lone pairs. Okay, so this is single bond, this is a triple bond. It is in a line which has 180 degrees. It is linear. Okay, and to figure out polarity, again, we go back to the Lewis structure. Are there lone pairs on the central atom? No, there are not. Is the central atom bonded to different elements? Yes, it is. Bromine is different than nitrogen. So since we answered yes to that question, this molecule is polar because it's not even. There are 2 different atoms on the sides. So this is polar. And we can see that when we look at the model here. We have bromine on this side, nitrogen on this side with the triple bond. So it does turn into a line, but we can see that this is clearly not balanced and symmetrical because this side is very different from this side. Okay. All right, so those are 4 examples. I think I'm going to stop the video and do a second video with the last 4 examples, a little bit trickier, but more of the same stuff. So if you want some more practice, watch part 2.